This is one of very interesting problems that I have because we use reverse Pythagorean theorem in this problem. There is no 90-degree angles to use Pythagorean theorem, but that's the idea of using reverse Pythagorean theorem. Question is, you are given the following ABC equilateral triangle with all sides equal to each other, which means all the angles are 60 degrees. And a point inside this equilateral triangle, this point P, and three segments. The distance from P to A is 2, from P to C is 1, and P to B is root of 5. So the first observation that I'm going to do in this problem is these three numbers, 1, 2, and root of 5. Two of them are integers, and the third one is root of 5. But the relation between them, you can see, is that if you do 1 square plus 2 square, that's root of 5 square, or 1 square plus 2 square is just 5. Here we see that these three numbers satisfy the formula of Pythagorean theorem, which means if I were to construct a triangle using these three segments, this PB, PC, and PA, that would have been a right triangle probably, because they satisfy the equation of Pythagorean theorem. So I need that triangle. I'm going to build that triangle somewhere around this. Figure. In order to do that, let me take this. So in order to build this triangle, let me take this triangle BPC. So one of these three triangles, and copy that triangle here. So these two pink triangles are exactly the same, because since they have common side here, this side and this side, they are equal. I just rotate the triangle like this 60 degrees and then get it right here, which means I have root of the length 1 here and length root of 5 over here, because that's the same as this pink triangle over here, right? So what are the angles? Now let's take a look at some of the angles. Let's say this angle is beta. Since this is the given initial triangle is equilateral, that's 60 minus beta, and this is also 60 minus beta, because this pink triangle and this pink triangle, they are same triangle, the congruent triangles. That's just the rotation. Now we can see that we have 60-degree angle here, so 60 degree here, so that's 60. So total XPC, XCP is a 60-degree angle, and we see that if I connect the, so let me use this. If I connect X and P, I get that 60 degree over here, and it is an isosceles triangle. So just pay attention to triangle XCP. Two of the sides, this side 1, this side is 1, and angle between them is 60. So the other two angles will be 60 and 60 also. Now we see that the triangle XCP is an equilateral triangle as well, a small equilateral triangle, which makes the other side here 1. Now here comes the interesting part. So pay attention to this triangle here. What are the sides? What are the sides of this triangle? So one of the sides is root of 5. Here one of the sides is root of 5. The other one is 2. The third side is 1. And we know that 1 square plus 2 square is root of 5 square. So that's reverse Pythagorean theorem. So when we see that the equation of the Pythagorean theorem is true, it means that it's a right triangle. So for example, so let me put the theorem here. Reverse Pythagorean theorem. So if you see a square plus b square is equal to c square, it means it is a right triangle. Like this. So that's what we have. So since 1 square plus 2 square is root of 5 square, this angle here, this part of the angle should be 90 degrees. So since alpha, our alpha is 90 plus 60, total alpha is going to be 60 plus 90 equal to 150 degrees.